Hello, in this video we'll be doing reduce everything again. So I just watched the Oz video where he did a walkthrough. I did not watch the walkthrough yet, but I got the guess that I should have read the title and properly and might have thought a bit more. So it says reduce everything. So in this exercise, there are several functions, and you can build everything with just reduce, right? And also you can compose reduce with itself, classic recursion, and it looks elegant. So I did take time to do all that before, so this is not I'm attempting for the first time. And I also tried recording a video, but I forgot to click the record button on my OBS. So anyway, so let's do a quick run through this exercise. So I'm gonna comment out all these functions. So again, one by one, right? And reduce, right? Before jumping into reduce, let's just take a simple example of adding numbers. If you're gonna add 1, 2, and 3 with init as 0 or maybe something. So the way the structure of this looks like is innermost is 0, right? Plus 1, deep inside, plus 2, and plus 3. I mean, I figured this out anyway. So this is how it applies. So at the core, when there are no excess, you just return init, and you just apply the function outside. And let's just see how to do that. So if there are no excess, I mean, if not excess, just return init, right? And if init is none, right? Take the first element as init and pass the remaining of the list to reduce itself. So return reduce, pass the function. So pass except the last element, because I showed you the structure, and pass the last element. If not, apply the function. So it requires an accumulator as a first argument. So I'm just calling the reduce again with excess except the last and the init, obviously. So, and then I'm gonna apply again, following the structure, the last element gets applied in the end. So the recursion goes like a deep tree. It's not a tree, a single thing. Probably like a list. I don't know, I'm just bad at describing right now, but it just goes a stack wise, and in the innermost stack, you just add the first element and the init, right? So here is the last element, and pretty much that's it. Let's just try running the doc tests. Reduce is working. Now let's head over to product. It's a simple one, so trying 3 times so I know just what it is. So reduce, pass a function that takes an accumulator nx and just returns accumulator to x because we are multiplying essentially, and you pass the nums and init is 1, right? Our product is working. Let's go to my map. Yeah, the mind bending thing is that you can implement this with reduce again. So I'm gonna do a later video maybe with trying everything out with reduce. Maybe most of all the functions in Lodash library. So again, return reduce, simple. It's just that pass a empty list as init and just keep appending or adding the transformed value to it. So lambda x, I mean accumulator x, and just return accumulator plus This means that two lists gets concatenated, transform the value of x, right, and pass xs and init as empty list. Reduce is done. Let's move on to my filter. Let me uncomment this out, get rid of pass. So f is a predicate function. I did a mistake of applying the transformation, or maybe just calling the function. It's just that add x, append x, if f returns true, if not, just return the accumulator. Essentially, it's that. So return reduce. What is that? Pass the function which I have to describe, accumulator, and then x. So accumulator plus x, which means I'm adding if f of x is true, else accumulator, pass xs and init as empty list. That's done. So let's move on to the last one. So I took some time to do this, but I was able to do on my own, so it gave me a good feeling. So let me break that down. So I'm gonna have some n containers, n being the length of each individual iterator for of that length, right? So I'm not doing any testing here, and the function is you essentially get the empty list and each individual iterator, which is x. Just enumerate means like get the index, get the value out of iterator for that particular index, which is the position of that particular list. You just add them. Add the value to that particular list. So it's a list to keep the structure consistent, and it's accumulator of that index, right, plus the element, right, for I and element in enumerate, what is that, x, and just call reduce on this. Reduce function, iters init, not int, init. Okay, voila. So it was fun knowing that that I could do this with reduce. Now I've got to go and see the walkthrough. Hope you had fun, and we'll see each other next time. Thank you.